Okay, go away. I'm not sure why that's even up. There we go. All right, so 38, 39, find the length and width if the length is 4 more than 3 times the width. The perimeter is 72. First, what's perimeter?
All the sides added up.
Okay, thanks. All the sides added up. So we're not worrying about what's inside. We're only worried about the sides. It's like if you were to walk around the fence of a yard. So, they didn't tell us the shape. But if you're looking at the length and the width, what shape do you think they're talking about?
Rectangle.
A rectangle. How would you know if it's a rectangle versus a square?
A square.
A square would have all equal sides. This one, we're already told that the length is different than the width. So I'm going to draw. I highly encourage that y'all draw shapes when you're trying to work problems like this. At least it works for me. I'm so visual. But I think it would help to kind of label things. So we know we're working with a length and a width, and we're going to have to find those. So let's get a little bit more figured out. The top, I'm going to call our length. So I'm going to put an L here. If that's the length, what's the bottom one? Length. It's also a length. That means over here would be our width. What's our right one? The width. So we know if one side is one measurement, that the side on the other is also that. So I'm going to put a dash or kind of a slash through length, meaning that they are equal. And then I'm going to do 2 slashes through the width, meaning they're equal. All right. Now, when we're solving an equation, we cannot work with 2 variables at the same time. So let's see what the information tells us. Hopefully we can remove one of the variables, replace it with some information. What is the word is? What does it mean? What symbol? Equal. Good, Lane. So we have right here, it says length is. So I'm going to go up to this L and I'm going to put an equals. 4 more than 3 times the width. How do I write that? 4 more than 3 times the width. Caroline Louise?
3W plus 4.
3W plus 4. Perfect. Now, W obviously is representing width. So we know from our reading, they don't tell us anything more about like the width is different of any sorts. So we'll just use W for width, but for length, instead, we'll write 3W plus 4 every time we need to use the variable L for length. Now, perimeter. Y'all have said we're going around. There's a template you can use. Carlin, what would you say? How would you tell somebody to find the perimeter?
2W plus 2L.
Perfect. So we need 2W plus 2L equals, and in this case, I'll put a P because it is for perimeter, but we're looking at a perimeter of 72. So 2W, 2L, that means to multiply them, obviously. It could also mean add, whichever way works. We're going to use multiplication though. So I'm going to change colors. I'm writing this one all over the place. So 2W, that doesn't change because we didn't have any way to substitute W. Then plus 2, but instead of the L, what will we put in its place? We'll put the 3W plus 4. So what does that mean you have to do with that 2? What are you going to do when you do what? Distribute. And then we're going to say it equals 72. So go ahead and work that part out. From now, I think you know to distribute, combine your like terms, isolate your variable, and we'll have what the width equals. So what is the width?
10.
It's going to be 8. Because you're going to take 72, but you're going to subtract 8. When you move the 8 over, don't forget when you cross the equal mark, your sign changes. Started off as a positive, traveled over as a negative. So if the width is 8, then we go back and say 3W plus 4 to find the length. So what's the length? 28. You would say 3 times 8 is 24. 24 plus 4 gives us 28. So did that work out for us? Does that make sense? Do you have any questions about it? All right. Go to, there's one more. Did not pass this one out. I was thinking you already had, so fly this back. Yes, ma'am. Yes, please have that calculator. This is where we'll really jump in. So on the back of the sheet that we were just working, and I passed you out one that's a little early for go ahead and flip over the page we were just working on. And we're faced with a big old word called a proportion. Who can remind me what the term proportion means? What are we talking about? Okay, in our case, most of them that we use, Bahar, will be fractions. They can be written as ratios. We could use decimals. But it's basically saying you have, yes, Mamie?
For equal.
They are. You have two fractions and they are equal. And the way you can determine if they're equal is look for a relationship, like here, between 6 and 24. That's a easy one that you know. But if you were given the fraction, say 3/4 equals 7/8, would we say those are proportions? Even though we have an equal mark in the middle, you need to always check that. The 3 times, you check by cross multiplying. If there's no relation, well, there is, between 4 and 8. How do we get from 4 to 8?
Multiply by
Multiply by 2, but then what's 3 times 2?
6.
6, not 7. So we know that this is really not a proportion. All right. Whoops. So what would our answer be for 40? We know we said 6 times 4. Yes, ma'am.
X equals 20.
X equals 20. Excellent.
Wait, how did we get that?
To get from 6 to 24
Oh, I get it.
is times 4. And then whatever you do to one part of a fraction, you have to do it to the other. All right. So we looked at 41. We have 5 and 6. We could add, but that's not how you work with fractions. You have to multiply. There's no relation there that we can easily grab. There's a variable in the numerator, so we can't even begin to determine what that would be. So we cross multiply. Now that means when you say 5, the denominator times its numerator, you're going to distribute that 5. It's not just 5x. You've got to also multiply it by the 2. So we would have 5x plus 2 equals, and what's 3 times 6? 18. So 5x equals?
16.
Yep. And then what would our final answer be?
A fraction.
It will be. And what is it? Leslie?
16 over
Distribute
5.
the 5 to the 2
Yeah.
as well.
Oh, I sure didn't. Thank you. Wait, what? Oh, I said for y'all to do it, and then I flaked. Thank you, Wesley. I was talking and writing. I was thinking that's not the answer I was looking for. Plus 10 equals 18. 5x equals, when you move the 10 over as a negative, We're left with 8. So what's our final answer? Do what? 8 over 5. 8 over 5, good. So if you were to take 8 over 5 and plug it in for the x and work it, you would end up with the numbers equaling each other. So 42, I want you to work that one. Being sure to distribute, not like I did. Do like I say, not like I do. So this one will give you a positive whole number. Lila, what'd you get?
10.
X equals 10. Are we good with that one? So you would have 4x plus 8 equals 3x plus 18. And then x equals 10. All right, 48, go ahead and work it as well. This one will not be as pretty.
48.
I'm sorry, my key is different. I've rearranged stuff. 43. I've moved some stuff around for this one. So 43. Not a hard one to work. So what did you get for x? Baylor, what'd you get?
I got 15 over
15 over what?
4. Over 4.
Perfect. Because any number times 1, so we would just have 4x equals 15. And so x equals 15 over 4. Now, of course, you could simplify that to 3 3/4, but you don't have to go any further. Good with proportions. Okay, butterfly method, if you will, or cross products, however you want to word it. So, this next set says write an equation. So we do need an equation. Then solve using your calculator. So, we are working with rates, the rate of something. This is still looking at proportions. This is just kind of a real world situation with proportions. So a quick question, what topics? There are 2 topics in this word problem. What are those topics? Goals and games. So I'm just going to put GO over GA. You could do GA over GO. It doesn't matter. All right? But when you make it equal, you put the topic across from it. So you'll still have GO over GA. Then when you read your information, you run across some numbers that go together. They're kind of like, they create their own proportion or their own ratio. What would that be?
15 over 15 and x over 1.
So we have how many games? We have 50 games that are related to the 15 goals. So I put goals first, and then I had my games. You could do games over goals. But then the other piece of information we're given is which topic? What else do we have? 120 what? Games. And what we're wanting to know is how many goals. So there's our variable. So one of 2 ways, you can simplify 15 over 50 and then work it. But you have a calculator with you. So all you have to do is cross multiply and solve for your variable. So how many goals? X equals what? Tully, what'd you get?
90.
Not 90,
36.
36. Let's look at something. You can simplify. Now, of course, you would have 50, do the math, but you could say 3 over 10. This gives it to you without you really even having to work. If you simplify, you'll end up with 3 over 10. And how do I get from 10 to 120? Times 12. And then 3 times 12 gives us 36. So either way, all right, look at 48, 49. This is where we're starting. Y'all have done the is and of, which is one way, is over of. I do it a different way just because I'm that visual, but you'll get the same answer. Hold on 1 second, let me move it up. What does what mean in any problem? It's a question, which means it's something we don't know. And what do we use if we don't know it? We use X, our variable. You could use J, R, Q, doesn't matter. I will use X. What does is mean? We've already talked about it. What is is? Equal. All right. We can't use percents as a percent, but we can rewrite it to what?
A fraction.
Well, we could,
Could you do 0?
but I'm going to write it, I want it written for this problem as a decimal. And all percents are based off of what number? 100, which means we're going to take the decimal point and move it 2 places to the left. So we would have 0.35. What does of mean? Times means to multiply. So you could really just multiply those two numbers together and come up with your answer. 14.7. Oh. So how would you set it up, though, if we did is over of? What's the other way? How would we do is over of? Isn't that what y'all would do? No?
Yeah.
Okay.
Wouldn't it be like x over 35 equals 42 over 100?
X, you could have x over 42 because it's the of. And then the percent is where you would come up with 35 over 100. That still has you multiplying the numbers. All right, either way would get you the answer. All right, then the next page. So 52 over 52, 53. 72 is 40% of what number? What is what number going to represent? X. There's our variable. So if you did is over of, what would you write?
72 over 100
Over X. And then what do I do with that percent?
40 over 100.
There's 40 over 100. Now, the other way is 72 equals 0.4 X. That's still going to have you dividing by 0.4, you would still, you'll get the same answer. But what answer is that?
180.
180. So find the tax only. So I'm not wanting to know the whole amount. I'm only wanting to know what tax they had to pay. If we had $75, or no, you purchased something for $75 and the tax rate is 8.5. So I'm not wanting to include the $75 in my answer. So tax equals 75 times, how do I write 8.5 as, yes,
0.085.
Baxter?
0.085.
0.08, I want to erase that. .085. And how would you set it up if you're wanting to do the proportion route? Hmm?
Would you multiply it?
Yes, you'll just have to multiply that. So what'd you get? $6.38. Now, I want to bring this up. When you did the math, you got 6.375. This is money. So you're only going to have a number to the hundredths place, and you need to round it. So that was good, $6.38. Are we good so far? We're not, and nobody's on the struggle bus on lost on what we're doing? Excellent. Oops. Let me get down. There we are. So, Will bought a four-wheeler. Oh, back up 56, 57. What is commission? What do we mean by commission?
When you money you actually tip.
Okay, it could be your tip. Sure. It is.
It's the money.
It's the money that. So if you sell something, usually it's salespeople that get the commission. Are they getting the entire price of what?
No.
No. They are only getting a portion of. So it's kind of like finding, like what with a problem like we just did. You're finding that rate. All right. So Will bought a four-wheeler for $9,000. Is that a good price, guys? I have no idea.
No.
Okay. I haven't bought a four-wheeler. And the tax was 9%. How do you write 9% as a point? 0.09. Now, this time the question says, what was the total price? So when you pay for something and you're told that the price is this, do you have to pay all of that? Unless it's on sale. But do you have to pay that whole amount?
Yes.
So he's having to pay 100% of the price and the tax. So we use what number to show that? 1. We throw a 1 in front of our tax. Alrighty? So then it's easy. Just 9,000 times, whoop, come on, there we go, 1.09. So how much did Will have to pay? $810. That's right. Alrighty. Then I think to the next page. page. Mason bought a $400 phone. Okay, been shopping. But he received a 30% discount. So he didn't have to pay the 30% discount. What did he have to pay though?
0.7.
The 70%. Good. So we're going to have 0.7 for our percent. Anybody have a question about where in the world did we get a 7? There's no 7 in the problem.
Because you subtract 30 from 100.
Yep. It's all percents are based off of 100. And if we didn't use the 30, we did have to use the 70. So what is the sale price? $280. So to set that up, we would also have it like this. So, $280. Okay, I put some papers on the floor or on the desk. If you would pass those back, they're clumps. So remember, take the entire, I kind of sat them sideways. You take an entire set for yourself and pass the clump back. You'll have 3 sheets. Be sure you have 3 sheets. They're 3 different sheets. Or did y'all take one and pass it
We
back?
need one more set.
Oh, it's 2 sheets because front, back, front. Sorry, front, back, front. 2 sheets, front, back, front. 2 sheets of paper, but 3 in the end. Okay, you should have one that says chapter 4. And then you should have one that begins 22 through 25. Everybody good? All right, let's get started. So what we've been doing, yes ma'am? We will later. I thought most was yours whole bunch? Huh. I don't know why not at all. They must not have all run through. How weird. Okay, we'll fix it. All right. So what we've just finished, those few days, chapters 1 through 3. This begins chapter 4, and it's pretty quick. All right, we're going to rock and roll. So we're graphing. When we are told to locate a number or a letter on the graph, and you're to write the coordinates, what are you being asked to write? Lila, y'all listen in, tune in. How do you write that? It's a what? No. X and Y. Thank you. That's your ordered pair. They're always written inside parentheses. And we call it an ordered pair because it's in alphabetical order. Okay? But where's X? Where's our X axis? Yep. And our Y axis is like Y, standing tall. And this also happens to be labeled. So where's E? What would be the coordinates for E?
Negative 2, 0.
-2, 0. Now it also says in the directions, there's a then. Name the quadrant or axis. What's a quadrant? Where is...
Like the square.
Yeah, so the first one, and they're written with Roman numerals. So the first one's right here. Second one is just to the right, to the left. And then you go down, 3. And then you end up going across, and that's like ivy, growing up a building, ivy. So what would we say for the location of E? It's on the X axis. If it's actually on the line, it's not in a quadrant. So X axis. What about C? What would be the ordered pair for C? 2, -1. And what quadrant? IV. It's in quadrant 4. All right. Then the next part, plot each point on the coordinate plane. Where would we place K?
2, 3, 4.
So I go to 2 on the x-axis and then up to 4. Put a dot and then please write the letter K there. Otherwise, you're just going to have a random set of dots. What about 10?
We go down
So to the left, 3. You know, always point. Oh, what's 0 called?
3. Like
What do we call the point where 0 is?
the origin.
The point of origin. That's where you start graphing everything. So go to your point of origin and go to the left 3 and down 3. And that will be N. Okay? All right, go to the back. And we have a set of ordered pairs. Anytime you have a set of ordered pairs, that's called a relation. Because they're going to all belong on the same coordinate plane and kind of hanging out together. So you've been told to make a map, a graph, and then the table. So the mapping is your X and Y circles over here. We need to put the X values in order, but you only list them once. So you put them in order from least to greatest. Same thing for the Y, and then you list them once. So what would be our X values? The smallest one.
Negative 3.
-3,
6.
6, and 9. What about your Y value?
0.
-5,
0.
0, 4, 6. Then you draw arrows from the X to its buddy in the Y factor. So from 9, we would go to 0. From 6, we would go to -5. From -3, we go to 4. From 9, we go to 6. And from -3, we go to 0. At a glance, how can we tell if something is more than a relation? How do we know if it's a function?
They will not have any share.
There will be no X's that repeat. Now, they can share Y's. Y's can be shown up all day long. But you can't form there's a vertical line test. You can't have that happening. All right? So, would this be a function?
No.
No, because the -3 and the 9 repeat. All right, I'm going to go ahead and write A, B, C, D, E. You can use whatever letters you want. So when you graph these, you'll use those points. How do you do the table?
Basically
You use the ordered pairs. Don't mix those up in a weird way. So the first one's 9, 0. You do a 9, 0. 6, -5. -3, 4. 9, 6. And -3, 0. That makes sense? All right. Then, what's domain? Remember?
the middle.
Nope. Domain is representing, it's just the X values. And you list them once. So basically take your map and go place it over here. And put it in those cute little doodaddies. So little brackets. So -3, 6, 9. What is the Y value? What do we call it? The range. What's the inverse? What do we mean by inverse? Okay, so we're going to take XY and we're going to write it YX. So we would have, did we change the sign? No. So like our first one will be, it's still an ordered pair, it would be 0, 9. So is the above relation a function? No. And the Y was, we had the variables, the X values that repeated. All right, looking at the last page, determining if it's a function, look at 24. Does the X value repeat anywhere? Or does it make it just a straight old line?
Makes a straight line.
Makes a straight line. It tells you in the directions, if it is a function, circle the problem number. Okay? That's all you had to do for that one. Then, if it's not a function, you're going to slash through the drawing. So, 25, is 25 a function? No, because you could sit here and draw straight lines through the points all day long. So, no. All right. Then 26, 27 says to determine whether the equation is linear. What makes it linear? There's some things that you look for. What can a linear,
We can't have an exponent.
no exponent. What about fractions? Can there be fractions? Actually, you can. You can just clear them. But what about variables in the denominator? No. No variables in the denom.
Good morning, boys and girls at Jackson Prep. Just a couple announcements for activity. There's a worship service in the gym today during activity. Also, if you're a senior and you've not had your picture made and then NPR, please go do that. Even though you've had senior portraits, this is
I'm
for
not
other
through,
reasons.
guys.
So please, if you're a senior, go get your picture made today. Thank you.
Also, you cannot have variables that are multiplied by each other. You can have a 3x, but you can't have variables multiplied by variable. So would 26, 27 possibly be? Yes. What about 28, 29? No, because it has the exponent. 30, 31? No, x and y are being multiplied. 32, 33? No, because we have the x and the denom. 34, 35? Yes, because we can clear. What would we clear by? 12. It says if they are linear to write it in standard form. What is standard form? AX plus BY. What type of numbers make up standard form? They're always what?
Positive.
Well,
The A's are
before we get there, the A is always positive. The B and C don't have to be. But the A, the B, and the C all have to be integers. They cannot be a fraction. They cannot be a decimal. All right.